The lesson outcome for this video is, I can solve quadratics by factoring using the ZPP, the zero product property, after getting the equation set equal to 0. Now this lesson is actually very much like the previous lesson, in that we are going to factor the quadratic, and then we're going to use the ZPP, the zero product property, okay, in order to solve the quadratic equation. But think about this for a minute. In order to use the zero product property, we need a product, which is an answer to a multiplication problem, that is 0. Well, right now, we don't have that. We don't have this equation set equal to 0. So that is why we need to first set this equation equal to 0. In order to do that, all we need to do is bring every single term to the same side of the equal sign. Typically, I bring everything to the left, especially if my x squared is already there, but it actually does not matter. So in order to do this, we are going to subtract 6x from this side of the equation to get rid of it on the right-hand side, and that means we need to subtract 6x from this side of the equation as well, right? Now be careful, because what happens here is people end up combining these two terms, but as we've talked about many times, x squared and a negative 6x are not like terms. So they can't be combined, they can just be written next to each other. So I will write x squared minus 6x equals, well, 6x minus 6x is 0. Now, this problem is actually exactly like the lesson we learned yesterday. We're going to factor the equation, or the expression, excuse me, on this side, and then we're going to use the ZPP, the zero product property, to solve. So at this point, we're going to factor this side, and notice we're going to always start with a GCF. There is a greatest common factor here of x. So we're going to factor that out, and we're going to keep this equal to 0 when we do it. So if I have x squared, and I take out one of the x's, I have an x remaining. That minus sign can come straight down. And now if I have 6x and I factor out the x, I'm left with a 6. Now I have an example of the zero product property that I need to use, because if I'm multiplying this times this and I get 0, that means one of these two factors has to be 0. It has to. There's no other option. So we're going to write either x equals 0 or x minus 6 equals 0. This one is already solved, so we're done. And then this one we're going to add 6 to both sides of the equal sign, and we're going to get x equals 6. Two solutions, two answers that will make this equation true if I plug them in. If I put a 0 in right here, 0 squared is 0. And does 0 equal 6 times 0? 6 times 0 is 0. So yep, 0 equals 0. What if I had put the 6 in to check it? What's 6 squared? Well, that's 36, right? And then what is 6 times the x value? And the x value we're talking about is 6. So what's 6 times 6? Well, that's 36. And does 36 equal 36? You bet. Okay, so let's try two more examples. All right, so again, in order to solve this equation to find out what x is, we need to factor it and use the zero product property. And in order to use the zero product property, this needs to be 0. So we're going to start by subtracting 9 from this side of the equation, as well as this side of the equation. When we do that, we get, again, do not combine any of these together. The like terms, remember, are based on the variable part. This is an x squared, this is an x, and this has no x's with it. None of these three terms can be put together. They can just be written side by side. So x squared minus 8x minus 9 equals 9 minus 9, which is 0. Now we've got a quadratic expression we need to factor, and in order to do that, because a is 1, this is an easier one, right? We're going to come over here and we're going to write our c term in this box. So negative 9. Negative 9 is 1 times 9 as long as one of them is negative, or 3 times 3 as long as one of them is negative. Which of the factor pairs helps me get this negative 8x in the middle? Well, negative 1 plus 9 is 8, but we need negative 8. So this is where we realize we need to change that to positive and that to negative. They still multiply to give me negative 9, but now they add to give me negative 8, which is what I needed. So I'm going to write my two sets of parentheses here. The x goes here and here, and we've got a plus 1 and a minus 9. And now we have two factors that when multiplied equals 0. Here's our first factor and our second factor, and it equals 0. If two things multiply and give me 0, one of those two factors must equal 0. So either x plus 1 equals 0, or x minus 9 equals 0 to make this equation true. We're going to subtract 1 from both sides of the equal sign here. We get x equals negative 1. And we're going to add 9 on this one so that these cancel here, and we're going to get x equals 9. Two values of x that will both make this equation true. One last example. X squared minus 15 equals negative 2x. Now this time, again, we first need to bring everything to the same side and make sure that our equation is set equal to 0. This needs to be a 0 over here. So we're going to go ahead and add 2x to both sides of the equal sign. Okay, now something a little bit different happens here. I just want to point out that again, none of these three terms can be combined. They're all unlike terms. But when you rewrite them, write them in the correct order. And what I mean by the correct order is write them in standard form, with the x squared first, and the x term second, and the constant term third set equal to 0. So I will write x squared, and I won't write minus 15. First I'll write plus 2x, and then minus 15. Writing it in standard form means that we're ready to factor it now. Once again, a is 1, so we can factor this by putting our c term over here in this box, and it is negative 15. 1 times 15 is 15, but we need one of them to be negative to get negative 15. 3 times 5 is 15, and one of them needs to be negative again. Which of these factor pairs adds up to positive 2x? Well, it's this one down here. So we're going to use those two factors in our parentheses. Put an x here and an x here. Again, when a is 1, these are a little quicker. We're going to write minus 3 and plus 5. Now we'll use the zero product property. X minus 3 equals 0, or x plus 5 equals 0 in order to get this equation to be true. We're going to add 3 to both sides here. And we're going to subtract 5 over here. And we have our two values of x that will make our equation true.